In this video, we want to look at how the sum and difference formulas for the sine and cosine functions can be used to work with problems with unknown angles, such as the one shown here. So in this example, we're given two angles x and y and two pieces of information about each of them. We're told that the sine of angle x is equal to 4/7 and that x is in quadrant 2. In terms of y, we're told that the cosine of y is -1 over square root 5 and that y is in quadrant 3. And using these pieces of information, we want to find the exact values of the sine of x plus y and the cosine of x minus y. So we have the sum and difference formulas that tell us that sine of x plus y will be sine of x cosine of y plus sine of y cosine of x, as well as that the cosine of x minus y is going to be the cosine of x cosine of y plus the sine of x sine of y. And so each of these expressions involves the four numbers sine x, cosine y, sine y, and cosine x, two of which were given and two of which we don't know. And so the first step in order to apply these formulas is to find the exact values of the cosine of x and the sine of y. And each of these can be done using right triangles. For angle x, we want to find the cosine of x where the sine of x is equal to 4/7 and x is in quadrant 2. And so we can do this by forming a right triangle in quadrant 2 and observing that we must have an opposite side of 4 and a hypotenuse of 7. The adjacent side must satisfy the Pythagorean theorem, 4 squared plus a squared equals 7 squared, which would be 16 plus a squared equals 49, or a squared equals 33. And so our adjacent side must be the square root of 33. Once we know this, then we know that the cosine of x will be formed from the adjacent side, square root 33, over the hypotenuse 7. But then because we're in quadrant 2, the cosine is negative there, so the cosine of x will be negative square root 33 over 7. For angle y, we're given that the cosine of y is -1 over square root 5 and that y is in quadrant 3. And so we can form a quadrant 3 angle and make a right triangle out of that. Here, the cosine is -1 over square root 5, so we know the adjacent side will be 1 and the hypotenuse square root 5. We can figure out the opposite side using the Pythagorean theorem. 1 squared plus the opposite side b squared is going to equal square root of 5 squared, or 5. And so b squared will equal 5 minus 1, which is 4. And therefore b is equal to 2. So we have an opposite side of 2. Once we have our triangle set up, we can see that the sine of y will be the opposite side of 2 over the hypotenuse square root 5. And because we're in quadrant 3 and sine is negative there, the sine of y will be negative 2 over square root 5. So now we have both the sine and cosine of angles x and y, and we can use these values along with the sum and difference formulas to find the values that we're being asked to find. So the sine of x plus y by the sum formula for sine, we know is sine x cosine y plus sine y cosine x. We now know all four of these values. The sine of x we were given is 4/7. The cosine of y we were also given as -1 over square root 5. The sine of y we just found to be -2 over the square root of 5. And cosine x is negative square root 33 over 7. We can then simplify this to become -4 plus 2 square root 33 all over this common denominator of 7 square root 5. And so this is the value for the sine of x plus y. For the cosine of x minus y, we follow almost the exact same strategy. We'll use the formula that this is equal to cosine x cosine y plus sine x sine y and make the appropriate substitutions. So the cosine of x is negative square root 33 over 7. The cosine of y is negative 1 over square root 5. The sine of x is 4 sevenths. And the sine of y is negative 2 over square root 5. Simplifying this expression, we're going to obtain positive square root 33 minus 8 all over 7 square root 5. And this is the value of the cosine of x minus y. Notice that in this example, we did not actually find the angles x or y. All we know about them is their sine and cosine values along with their quadrant, but we did not need to actually find the measure of either angle in order to determine the sine or cosine of their sum or difference. If you'd like to practice with a similar problem, suppose that the sine of an angle A is 3/5 and A is in quadrant 1, and that the cosine of an angle B is negative 5/13 with B in quadrant 3, and use this to find the cosine of A plus B. The correct answer will appear in just a few seconds. So here we can use right triangles in the appropriate quadrants to see that the cosine of A will be 4/5 and the sine of B will be negative 12/13. And once we have those two values along with the given values, we can just simply substitute into the sum formula for cosine and we obtain a final value of 16/65.